David Cann here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook, Chapter 2, E.2. In this question, we're dealing with a theater with 20 rows. There are 15 seats in the first row and 17 seats in the second row, so the number of seats has grown by 2 as we get further away from the stage. Each successive row has 2 more seats, so the third row would have 19 and the fourth row would have 21. It says, now calculate the number of seats in the 20th row. Well, I suppose we could just go row by row and add 2. Or we could take advantage of the fact that this is an arithmetic sequence because each row grows by a fixed amount, the common difference. So for part A, we'll say that this is an arithmetic sequence, so it follows the formula un equals u1, so the general term is equal to the first term plus the common difference times n take 1. We're looking for when n is 20, so when we have the 20th row. So if n is 20, then we get u20 is equal to u1, that's the number of seats in the first row, plus the common difference, that's 2, times 20 take 1. 20 take 1 is 19, times 2 is 38. So this is 15 plus 38, which gives us a total of 53 seats. So there are 53 seats in the 20th row. We want to use that information now to calculate the total number of seats. So this is a summation. We want the sum of an arithmetic sequence, that's the number of elements in the sum, times the average of those elements, the average term, which is the first term plus the last term over 2. So in this example, we're dealing with 20 rows, so we want the sum of the first 20 rows. That means we have 20 elements. The first element is the number of rows in the number of chairs in the first row, that's 15 seats, and the number of chairs in the 20th row, and we determined that was 53 seats. Divide that by 2. 15 plus 53 is 68. Divide that by 2 is 34. 20 times 34 is 680 seats in total.